Welcome back, everyone, to the Deep Dive. Today, we're digging into something really quite remarkable, a discovery that, honestly, could significantly shake up our whole global energy picture. We're talking about white hydrogen. It's naturally occurring, clean energy,
hmm
and it's literally been hiding right under our feet.
That's a great way to put it. And yeah, our main source for this is an article called White Hydrogen, the surprising new clean energy hope.
Yeah.
So our mission today is basically to pull out the key stuff from that, help you get your head around the huge potential, but also the real hurdles involved.
Okay, so let's start with hydrogen itself. On paper, it always sounds like the dream fuel, doesn't it?
Absolutely. The theoretical appeal is massive.
I mean, you burn it with oxygen, you get water, that's it, no nasty emissions. Plus, it's efficient, clean, and you're not relying on fossil fuels from geopolitically tricky places. So if it's so perfect, why haven't we been using it for decades? What's been the holdup?
Right, that's the question, isn't it? And as the article points out, it nearly always comes back to one thing: production. Making the hydrogen in the first place. It takes a lot of energy. And that brings us to what people call the green hydrogen problem.
Ah, okay. And this is where it gets really interesting, I think. Because, for all that clean theory, the way we actually make most hydrogen today, it completely misses the point. The vast majority, comes from natural gas, sometimes coal, which,
hmm
let's face it, just creates massive co-zero emissions. So much for clean energy. And just so we're clear, even the other types, like gray or blue hydrogen, they still come from fossil fuels. Maybe they capture some carbon, maybe not. Still got that carbon footprint.
Precisely. And even the supposedly ideal green hydrogen, the kind you make by splitting water using renewables like wind or solar, well, it's still got major drawbacks. It's generally very expensive. It's pretty inefficient to do at scale. The limitations are quite real. The article actually mentions this big EU initiative, right? Billions poured into green hydrogen. But lots of companies actually pulled out. Why? Because it just
Yeah.
wasn't efficient enough, too costly.
Okay, so manufacturing hydrogen, even the green way, is a huge challenge. Expensive,
Mhm.
inefficient. So what's the alternative? And that, I guess, brings us neatly to white hydrogen. Nature's hidden gift, as they say.
Right.
This is the hydrogen that's
Yeah.
just there. Naturally occurring molecular hydrogen trapped underground in rocks. And the crucial difference here, and this is kind of the mind-blowing part, you don't make it. It's already made.
Yeah, it's already there. And the way the Earth makes it is pretty fascinating. The geology is amazing. Our sources talk about a few key processes. One big one is serpentinization.
Serpentinizer, right?
Yeah, basically you have these iron-rich rocks, like peridotite, deep down. They react with water, especially hot water. They effectively, well, rust. And that process releases hydrogen gas. Then there's another way, radioactivity. Unstable elements deep in the Earth's crust.
Mm-hmm.
They decay, release radiation, and that energy can actually split water molecules apart, creating hydrogen. And there's even the thermal breakdown of really old organic matter, like fossils, deep underground. That can release hydrogen too. It's like the planet itself has these little hidden hydrogen generators chugging away.
It's actually incredible when you think about it that way. Just quietly being made under our feet. And look, this isn't just theory anymore, is it? People are actually finding this stuff. We read about those discoveries in France in the Lorraine and Moselle regions, boreholes hitting hydrogen concentrations up to 20%.
Yeah, 20%, that's a really high concentration, geologically speaking.
And the estimated value, I mean, take it with a pinch of salt maybe, but over $90 billion for those French reserves alone. Though, yeah, scientists are saying, hold on, it's early days, we need more data.
And that's fair enough, but what's really interesting is how fast the science is moving now. There's this research paper in March 2024, just this year. It took a much bigger view, a planetary scale. They essentially created the first global map showing where natural hydrogen is likely to be found. They did it by cataloging all the geological processes known to produce hydrogen and mapping where those conditions exist. It really shifts the thinking, from manufacturing hydrogen to prospecting for it, like oil and gas, but for hydrogen.
And that map, what did it show? Any surprises?
Well, some areas weren't that surprising. Places like Russia, Canada, the US, Australia, big land masses, diverse geology. Makes sense they'd have potential.
Right.
But there were definitely some more unexpected locations highlighted.
Oh, yeah, like where?
Well, Mali, for instance. They're apparently already extracting some natural hydrogen from a well there. It's been happening quietly for a while.
Wow, okay.
Then you've got places like Oman, parts of the U.S. West Coast, even Cuba popping up as potential hotspots, often linked to ancient ocean floor geology pushed onto land. And this leads to another really interesting point for finding it: helium.
Helium, how does that connect?
Well, the thinking is that helium, which is also generated deep underground and is very light, often leaks up through the same pathways that hydrogen might use. So if you detect helium seeping out at the surface, it could be a signpost, like big here for hydrogen. It could become a key exploration tool.
Interesting. So mapping helium seeps could guide the hunt. Makes sense. Okay, so with these discoveries, the mapping, it's definitely not just academic anymore. You're seeing money move, right? Commercial
Wow,
interest.
absolutely. It's starting to explode, really.
We saw mentions of companies in the U.S. like High Terra out in Kansas
Mm-hmm.
and Colmer in Denver. That's the one backed by Bill Gates and Jeff Bezos, right?
That's the one. Big names getting involved already.
And it's not just the U.S. Europe's getting in on it too. GTEC in the U.K., Helios in Spain, Japan's interested as well. It really does feel like the start of I don't know, a global race.
It does, but, and this is important, there's still a lot of skepticism, and probably rightly so at this stage. Our sources definitely urge caution about the practical side, getting it out of the ground efficiently and affordably. There was that slightly cynical quote in the material, wasn't there, about Europe?
Oh, yeah, I remember that one. Something like, Europeans won't extract the hydrogen. They'll just write a 500-page regulation about it.
Yeah, that's the one. It's obviously a bit tongue-in-cheek, but it points to a real potential issue, right?
Hmm.
Bureaucracy, practical hurdles. And the challenge isn't just finding it, it's understanding these underground systems. How much is there? How fast does it replenish, if at all? And how do you get it out without, messing things up? It might need a much more surgical approach than traditional drilling.
Right. So let's try and pull this together. What does it all mean for you listening? The potential seems, well, revolutionary. But it's wrapped up in some big unknowns. The shift seems to be from making hydrogen to finding it. But how we find it reliably, how we extract it, what it costs, still big question marks.
Exactly. And if we connect that back to today's energy plans, the advice seems sensible. Renewables like solar and wind, they're here now, they work, they're still our best bet for the immediate future. Keep rolling those out. White hydrogen is this incredibly exciting frontier being explored, massive potential,
Yes.
guaranteed game changer tomorrow. Not yet. Needs a lot more science, a lot more engineering.
Yeah, it's a fascinating prospect, though. If they can crack the extraction code, make it affordable, it could really be a paradigm shift. And it's just a cool reminder, isn't it, that the Earth itself, these deep geological processes, still hold these untapped energy secrets.
Absolutely. The path ahead isn't clear, but it's definitely promising. It feels like chapter one of a whole new energy story is being written. This global hunt for underground hydrogen is really just kicking off.
Definitely one to watch. And look, if hearing about the science behind energy, or frankly any complex topic, gets your brain buzzing, you really should check out brilliant.org. It's this amazing interactive learning platform, math, science, computer science. They made complicated stuff genuinely understandable and, dare I say, fun. They use these interactive visuals, little puzzles, and challenges. So whether you're curious about, I don't know, quantum mechanics like we mentioned, or maybe differential equations, Brilliant has courses that actually make sense of it all. You can get started for free. Just head over to brilliant.org/Zabina. And here's a bonus. The first 200 people who use that link will get 20% off an annual premium subscription. So that's brilliant.org/Zabina.
Definitely worth checking out. And maybe just to leave you with something to think about after this deep dive. Consider how a totally unexpected discovery like white hydrogen might force us to rethink our entire global energy strategy. And maybe ask yourself, what other hidden energy sources might nature be holding on to, deep underground or elsewhere, that we can barely even imagine today?